In this lesson, we're going to investigate Java's exception handling mechanism. Exceptions are the way that Java reports error situations, and the mechanism allows us to create code that controls our program's response to those errors. We'll use this project, readerFile1, and build on that. Right now, the program attempts to read a file, text.txt, and print the lines out onto the console in this loop. If the file doesn't exist, or if there's a problem like a damaged disk during the reading, then the program just quits. We've labeled the main method as throwsThrowable. That's a crude way of saying when bad things happen, just give up. You shouldn't do that in a production program, but it's great for learning from. Well, the first thing that we might want to do to improve this is to take control of what happens when the file is not found. Java gives us control of exceptions using a try block. Let's start by taking out this throwsThrowable part and see where that takes us. Immediately, the compiler complains about the two lines that might fail. Let's click on this red error blob and see what it says. Hovering, it just says unreported exception java.io.filenotfound exception. But when we click on it, it offers surround statement with try catch. Let's go ahead and try that. See what it's done. It's created this block around this statement that could fail that says try, and then goes into the curly braces, and then it says catch file not found exception. Remember, that was the exception that it was saying might go wrong here. And then inside the catch block, it has this rather ugly looking logger.getLogger blah 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 .log, which you can probably guess is going to attempt to send a log message to report what went wrong. Well, we're not really interested in some ugly log message, though we'll leave it in place for the time being. What we probably want to do is to send an error message out to the console that we can actually read. That log message might do something similar, as it turns out. But let's say system.err.println file was not found. Now, we've looked at system.out many times, but system.err is actually the system's error channel. It'll just show up on the console in NetBeans in red, but other than that it's the same. And if you wanted to, you could have said system.out just as easily. Well, there's another problem, look, down here. This one is now saying variable fr might not have been initialized. Well, that is because fr gets initialized in here where we say fr equals new file reader. Unfortunately, up here, there's no initial value for it. So what we'll do is say equals null. That should make that problem go away. Let's actually move this buffered reader constructor inside the try block. That actually causes another problem. Notice down here, this BR, which should be that one, isn't found. This is quite a common situation when you have try-catch blocks. If you declare the variable outside the try-catch block, then it's in scope beyond the try-catch block. But if you declare it inside the try-catch block, then it isn't. So this is only visible between the enclosing curly braces. So what we'll need to do is to take the declaration outside and change that so that it's not a declaration. And again, we see variable might not have been initialized. So we'll set this to equals null. The point, of course, is that if this statement explodes and creates this exception, then we'll actually end up out here after we've caught the exception, and we won't actually have ever set either of these values potentially. And the compiler is very fussy about knowing that things have been initialized. Well, the other problem is we have this potential exception down here as well. And this one says unreported I/O exception. That just means things can go wrong sometimes when I/O is happening. So for example, if the disk was corrupted, then it might have managed to open the file, but it fails partway through reading it. Let's click on this thing again, and we'll say surround statement with try catch. And this time you'll notice it's surrounded the entire while loop, because that's one statement, with try catch. And we've got, again, this rather ugly logging message. Well, we'll go with that for the time being. That's not a huge problem. Now we don't seem to have any complaints from the compiler any longer. So let's give this one a try. We will save it, and then we'll run it. And it seems to work again. This time, let's see what happens if we change the name of the file we're trying to open. We'll just change it to something that doesn't exist. The only file that exists in this project is currently called text.txt, and so there's nothing called non-text. So if we run it again, this time we get a whole bunch of red output, and you'll notice the very first line says, "File was not found." And that's the error message we created there. Then immediately afterwards we get the output of this logging message, which you can see is a little bit more verbose, not necessarily more helpful, but it does explicitly say non-text.txt, no such file or directory, and then the body of the exception tells us the line that the error occurred at, and so forth. Interestingly, it carried on after it ran the catch block, and it actually also failed here when it discovered that BR was still null. And so that causes a null pointer exception. 2 exceptions in one program run. It's pretty good going. Let's review briefly what's happened so far. The compiler knows that the constructor of a file reader might fail and might throw an exception. Because of that, we are forced to surround that with a try block and to have a catch block that names that exception, or possibly something more generalized, and this catch block will be invoked if this exception arises at this point. So there's a couple of paths through here. The first is we come down, we hit the try block, we create the file reader, it works, we create the buffered reader, and then we'll carry on from here, having not run the catch block. The other possibility is that we construct the file reader and it fails. That throws this file not found exception, so the execution jumps straight from here into here, prints out this message, prints out this rather complicated logging message, and then carries on. As far as Java is concerned, if you catch an exception, it assumes that you fixed the problem, and it will carry on after the catch block. Because of that, therefore, it goes into here, goes into this try block, and then this try block actually has a null pointer exception in this case because BR was never set up. That isn't really what's supposed to be going on there, so that's not of prime importance to us. So we have 2 possibilities. No exception arises, we run through the try block, we ignore all the catch blocks, we continue. The other possibility is somewhere in the try block, the exception arises, it skips into a catch block that names the type of exception we're interested in, it handles the catch block, and then it carries on afterwards. Well, clearly, this kind of exception handling, really just logging the error and then failing anyway, isn't terribly useful in the real world. What we'd like to be able to do is to go round and try again. So one of the classic situations we'll end up with is that we need to build a loop around this attempt to read something. We're going to build that by attempting to read something from the keyboard, so that way we can keep giving different file names, and each different file name can cause it to fail or succeed accordingly. The way we read the keyboard is like this. We start by creating an input stream reader attached to system.in. System.in, as you can probably guess, you've seen system.out and know that sends output to the console. System.in reads from the keyboard. Unfortunately, it reads the 8-bit characters in whatever the platform's native character encoding is, and Java wants to work with 16-bit Unicode characters. So what we do is we attach this thing called an input stream reader onto our keyboard input. Input stream reader takes 8-bit characters in whatever the local platform encoding is and turns them into 16-bit Unicode characters. And of course, it's a reader interface that allows us to read characters in the usual way. But we want to be able to read a line at a time, so we attach a buffered reader onto the input stream reader. Now we have this buffered reader that we're calling keyboard that will allow us to read from the keyboard a line at a time in proper Unicode characters. The next thing we'll need to do is to build a loop around the whole attempt to open the file. In order to control that loop, we're going to need a variable, a flag that says success is false initially. So the idea is we start out with this flag set to false, and as and when we've succeeded in opening the file for reading, then we'll set it to true, and that will stop our loop from going round and round and round. So I'm going to replace this with a loop that will allow us to go round and attempt to read this file. So here you'll see we say while not success. Remember that exclamation mark symbol is Java's way of saying not. So while we have not succeeded, we'll print out this message to say enter the file name, and then we have a declaration of a variable that we'll use to hold the file name we've attempted to read. Then in our try block, we've got a slightly modified behavior here. We read from the keyboard one line and we save that as this file name. Then we attempt to construct the file reader based no longer on constant text, but on the file name we just read. If that works, we carry on and attempt to create the buffered reader. If we're still successful at this point, then we set our success flag to true. If, however, our attempt to read the keyboard fails, this actually can throw an exception, as it turns out, and what that would be a general I/O exception. So there's a catch block for the general I/O exception that says failed to read the keyboard. It's fairly unlikely that'll happen. The other possibility is that the attempt to create the file reader failed because we still didn't have the right file name in there. For that, there's a catch block that catches the file not found exception, and that prints out file name was not found, try again. Now at this point, I actually want to finish that loop, so we'll put the closing curly brace in, reformat the code. Now there's a couple of observations to be made here. The first is we actually now have two catch blocks because there's two things that might go wrong in what would otherwise be our happy path. So if everything works, we come into the try block, we execute each of these 4 lines, that sets the success flag to true. We carry on after the end of the catch blocks, which takes us to the loop, and the loop then terminates because success is now true. However, if the keyboard read fails, it throws an I/O exception and comes in here. If the file reader construction fails, it throws a file not found exception and jumps in here. One thing that's important to know is that file not found exception is actually a specialization, a subclass of I/O exception, which means that if we didn't have this catch file not found exception block, we'd actually jump into this exception handler anyway. Because this is more specific than this one though, if we put this as a catch block first, we can catch just that exception here, and any other kinds of I/O exception will be handled here. If we tried to put these in the wrong order, the compiler would complain because it would point out that everything was going to hit the first exception handler that matched, the I/O exception handler, and that the file not found exception would never catch anything if it was underneath. Think of these exceptions as being thrown up and then they drop down into the first available handler that matches them. So now let's try running this one. We'll make sure it's saved and we run it. It says enter file name. We bring the focus down in here and we'll say rot. File was not found. Try again. And then we say text.txt and it goes ahead. All this succeeds, sets the success flag to true. That causes the termination of the loop. And then it comes down into the same piece we had before, where it reads the lines one at a time and prints them out. So there we have it, a quick overview of Java's exception handling mechanism. There is more to know. Notably, there's a finally block that could be placed in here, but this isn't the lesson to discuss those.